Okay, what did we do yesterday? We built a simple server application, a TCP server that triggers a message whenever a particular file is changing, right? So let me open that. Right? So we wrote a simple server that opened the connection, and anytime, whenever a user connects, right, it starts watching for a file, and whenever the file is changing, it sends a message to the server, so to the client, saying that the file has changed. Now I asked you to write a simple client that can connect to this. So we wrote the client yesterday. No, we didn't. So let us create a simple client. So new file, the client.js, where net is equal to require net, and then where client is equal to net.connect a particular port. So you can say the port number is whatever is the port number that is given here. We are listening on port 9090, so let us say port 9090, right? And then we can keep listening for messages coming from the through the connection. So we'll say client dot on the data. So whenever the data event is triggering, function receive the message from the connection, and simply say console.log whatever is the message arriving from the connection. And we'll say console.log client listening, right? Client running. Client running. Now let us open the command prompt. Right? Network. First, let us go to the server and now run the server. So we need to give the file name, right, that we want to watch. So let me say the file name is node server test.txt. Now this guy is listening on port 1980. Here is your client. Now let us open one more command prompt. Right. Client, and then we will say node client.js. Now you see that the client is listening, and here it says a new connection is established, right? Now all we need to do is just open the file and make changes. So if I make changes to this particular file, you'll find that the server recognizes it and automatically sends a message to the server. So let me say Control S. This guy sent a message to the server and to the client, and the client has received it, and it is printing, right? So it has received it as a buffer and it is printing it. Now we can very easily convert it into a string, and we can print it to the console. So how do you do that? Let me show you how you can do that. Just give me 1 second. We convert that into string to string. Let me simply modify the file. Okay, so all we need to do is just, all we need to do was just create a toString on that, and it automatically gave this, right? So I just converted it into a toString, and whatever buffer that came, it is automatically printing it as a string. So here, if you look at the client, you'll find that, sorry, there's a different window. So that is our window. Here is it, right? It says the file is changed at this particular way. Now, what we want to do actually is send messages in JSON format, right? So we'll send a message in JSON format and see how your application behaves when the messages are sent in JSON format. Now, we haven't handled the error conditions here. So if we handle the error conditions, we can access these error messages and handle accordingly, right? So how do you handle errors? Basically, simply you just need to listen on the error event, right? So client.on a error event, and then based on that you handle the error. Okay. Now what we will do here is whenever the connection is established, right? So we will initially send a message saying that we have started watching for a particular file name, and whenever it is changing, we will send a slightly different message, right? So here, what we will do, instead of this console.log, okay, so console.log is fine, and when the connection starts, right? So when the connection starts, I'll simply say connection dot write. What is it we want to write? We want to write a JSON.stringify of an object. So basically, we want to write an object, right, in string format, so that the other guy can receive it. So we'll say type is watching. Type is watching, and what is the name of the file, right? So file name is the file name, right? File name is the file name. Now on the other end, we will have to receive this and parse it as a JSON object, and then we need to display a different message. Let's assume that we want to display a different message. So on the other end, what we can do, on data, we will receive the actual data as a string, right? So let us receive it as an object. So where response is equal to JSON dot parse the message. Now I'll say switch based on what, the response dot type, right? Switch based on response type on what? On a couple of things. Number one, case watching, right? If it is the response type is watching, what I want to do is I just want to display a message. So console.log watching changes for file plus the response dot file name, and we will break. Okay, and then similarly, whenever the file is changing, we are going to write a slightly different message. So let us go here, and instead of this, I'll say connection.write. This is file changed. Okay, so that's a watching event, and this is a change event. What has changed? A file has changed. When it has changed, so timestamp. So I'll say timestamp is let's say date dot now, right? So this is when the file has changed. Now on the other hand, here let us start listening to it. So case change, right? If it has changed, then I want to say console.log file changed. Which file? file plus response dot file name changed at response dot timestamp, right? File change at response dot timestamp. We'll say a break and then default. If it is anything else, we'll simply say console.log unknown message, and we'll simply say message.toString. Okay, message.toString, and we'll break. So here is our switch case, and this is what we want to do when a message is received. Now let us run the server. So start listening on port 9080. Let us go to the client and let us run the client. So node client plus is missing. Thank you. Thank you. Right. Node client. Now you see a new connection is established. Here this says watching changes for file, the file name. Right. Now let us go back here. Let me slightly modify the file and say the file most likely. Oops. Unexpected token I undefined. There is an error. Connection reset. So basically this connection was okay. So we'll try to print the message as it is once before we console.log whatever is the response. So let me start listening on it. It is Zen. Okay. See here, this is the message that you received. So type is watching, file name is this. Now when I change the file, when I change the text, save the file. Now file change that undefined one. So there is some problem with the parsing logic. One second. So let me look at the server. Type is change, file name is file name, timestamp is datetime.now. Is that the problem? Is that the problem? Okay. Okay. So it looks like the string was the problem. This value was the problem. Right? So once we converted into a string, it seems to be printing. But why is that a problem? Timestamp a string. What is the datetime.now gives you usually? Date.now. Yeah, but why when converted into a JSON string this is a problem? So JSON.stringify of an object, let's say timestamp is date.now. Yeah, there shouldn't be a problem. Then why it be a problem? Okay, anyways, so now we have received this, right? So we have received this particular file. But now what can happen is when you send, see here the assumption is that the file is being, the messages are being sent in one chunk, right? And the messages are being received as a same chunk. The messages are sent in one chunk and they are being received as one single packet. What if the message reaches in two different packets, right? So what if you write the message in different, the message, half of it has reached and then the other half reaches a bit later, right? So what happens in that particular scenario? Now what will happen is your application will break. For example, let us take this. Now let me manually convert this into a string. So a string, a JSON string, is very simple to create. We will write this. So this is our string, right? So let me take this whole object and create a string out of it, where response is equal to a single quote, drop this whole line, and type is a double quote, and this is also within double quotes, comma, the file name will be in double quotes, and the name of the file will also be in double quotes, right? The name of the file will also be in double quotes. So single quote plus double quote plus single quote double quote, comma, and the timestamp, right? And the timestamp. So the timestamp will also be in double quotes. The field name will be in double quotes, and this will also be in double quotes, single quote plus the value plus single quote double quote, and close this, right? So here is your complete message. So if I take this, right? So if I take this and let me see, let's go to the browser, and what we will do is say file name is equal to abc.text and paste this variable. Now if you look at what is response, it is a perfect JSON string. So simply say json.parse this response. It can be very easily parsed into an object, right? So we have created a manually we have created a string that can very easily be parsed into a JSON object. Now what I am going to do now is I am not going to write the string as it is. I am not going to write the string as it is. So this is going to be made as response 1, and I am going to break this as response 2, right? I am going to make this as response 2. Now we are going to manually artificially generate a time delay between these two messages. So I am going to say connection.write response 1, right? Connection.write response 1, and then a set timeout of a function where we will say connection.write response 2. Okay, and when is this going to happen? After a second, after a couple of seconds, whatever. Okay, now so basically what we are doing is we are simulating a network delay between two different packets, one packet carrying a part of the message and another packet carrying the other part of the message. Now let us shut this down. Is this keep running? Right? So let me shut this down and restart the server, and here let me restart the client. Now let us try to change the file. So when I try to change the file, what might happen is save it. Now see here, it has received only a part of the message which it is unable to parse, which is quite understandable, right? Which it is unable to parse. So now what we want to do is we want to use a component that will keep receiving the message and break it based on a new line. Okay, so break it based on a new line, and until it reaches a new line, it will keep reading it, and then parse it and then return the result. Okay, so we will use a component that will emit an event, that will keep receiving the message from the network stream and then parse it. As and when it reaches, it receives considerable data, it will emit an event, and so that the client can process it. Okay, so that is what we are going to do, which I have already written. So the parser that we want to write is called as, we have named it as LDJ. LDJ is line delimited, JSON file, right? So it's kind of a custom format. Think of it as our own custom format. So we have a line delimited JSON format. Now the way this has been written, right? So I'll name it as ldj.js. Now the way this has been written is, we know very well that most of these components emit events. So we say connection.on data, connection.on error, right? So most of these components emit events. Now, and how is that all the APIs expose the same methods using which you can subscribe to those events, right? There is no add event listener, nothing. So every component exposes the events as on, right? So how is that all the components expose the events in the same method name? The event names may be different, but the method names are just the same, right? How so? It is because if you look at node.js.org/API, you have a module that acts as a base for emitting events, and the module name is called events module. Right, and the module name is called events module. So the events module has an object, a base object called events emitter, that has all the utility methods using which you can emit events in your own components. Okay, so you see here emitter.on, emitter.once, add listener, remove listener, etc., etc., etc. Now all the events APIs, all the APIs in Node.js that emit events inherit from this event emitter, right? So automatically they get the capability to emit events, to publish events, and as well as to accept subscribers. Okay, so this is kind of a base class for all APIs that emit events. Okay, except that it doesn't become the raw base. Basically what you do is you use mixins. You copy the attributes from this base class to create your own API that emits events. And how do you do that? That is done using this. So if you look at here, what we have here is we have loaded the events module. We are loading one more module called util. I'll explain you what is the util here. And then we are creating our own custom, our own constructor function, right? An LDJ class. We are creating our own constructor function, and this constructor function takes a string as an argument, and then internally we call the events emitter. We call the events emitter function, passing the current object, right, your LDJ, as this reference, and then we create a closure under this, initialize a variable for the buffer, and then we subscribe to the data event of the string. As and when data comes, right, as and when, every time the data event triggers, we search for a new line character. If the new line character comes, then what we do, we take the data till the new line character, right, we check for the boundary. If the boundary is not equal to -1, which means that there has been a new line character, so you take the data till the new line character, buffer.substring of 0, boundary, and then you reset the buffer, right? Buffer equal to buffer.substring from boundary. So you reset the buffer so that it contains everything other than what you have already extracted, and then what you do is you emit an event. You see, self.emit, you emit an event by name message, and what the message carries? The message carries the parsed data from the input, and then you say buffer equal to boundary equal to buffer dot index of -1. You reset the boundary so that the loop continues. So if you have already received two messages, two JSON objects, right, which carry two new line characters, then you might want to do this again and again and again, right? So you keep doing it until you reach -1, and then you wait for the data event to trigger, right? So now here we bring in a component, right? Here we bring in a component. This acts as a kind of a pipeline. Okay, so it takes the data from the stream and then treat the data coming from the stream as raw data and parses the raw data and then extract meaningful information. As and when it extracts the meaningful information, it emits an event, right? As and when it extracts the meaningful information, it emits an event. And now on the client side, right, we simply need to use this guy, right? We simply need to use this guy. So how do you use it? Let me show you. So this is your client that is using the delimiter, right? So we'll say this is client-ldj.js. So here what this guy does is he loads the line delimiter JSON module that knows how to parse the JSON files based on the new line character, and you create a new instance of this parser passing the connection, which is nothing but your string, and then you keep subscribe to the message event, right? You keep subscribing to the message event, and if it is watching, then you handle it in one way, and if it is changed, you handle it in a different way. Is it changed or changed? It is changed. So if it is changed, you handle it in a different way, right? It is timestamp. This timestamp. So you change it in a different way. If it is something else, you simply say unknown message, right? Now this is the way by which you can create your own components that emit events. So let us experiment with this. Let us go to the client server. Let me run the server. Let's go to the client. Let me run the client. We got a message, right? Now let me modify the file. Let me modify the file. So simply modify the file, save the file. You should find that. Okay, so I ran client.js. I'm sorry, I should have run the client LDJ, right? Our new implementation. So which is client-LDJ. So here is our new implementation, and it's a connection refused. It says an error. Okay, sorry, the port number is different. So it is 90. I'm listening on port 90. Right? So now a new connection is established. Now let's go here, modify the file. So when we modify the file, introduction. Oh, sorry, we haven't returned the new line. Okay, so our server has to write it with a new line. So we didn't write the new line part. We'll say this is +/n. Okay, and similarly this has to go with the /n. So it's my mistake, because our parser is returned to emit a new line. So my mistake, just sorry, 1 second. send, and this is MBJ, there it is, right? So watching undefined, forget about the file name. I think there is some confusion with the attribute name. Now let us modify the file. So when I modify the file, even though the message reaches in two different forms, it is undefined one. I think once again the problem is with the okay, I think the backslash is the problem. What we will do, we'll send only the file name. What I have done is I am sending the whole path. We'll just send only the file name. So what is the file name? Required path is file name. I am overriding the file name. Is it still sending the whole message? Okay. Oh, okay. The problem was with our manual serialization. If we do JSON.stringify, right? See, in this case, we are doing JSON.stringify. So what happens is the path is automatically escaped, right? So each backslash is replaced with two backslashes. But if I am doing the manual serialization, I broke it into two lines and I am doing the manual serialization. So when I do that, right, so that escape does not happen. So that was the problem. The path escaping was not happening. Okay, now let me modify the file, and when I modify the file, the message is sent. You see that now? Right? So initially you received this message, and then after some time you received this message, but still your middleware is able to receive the message, wait till it reaches a new line, and it is able to parse it, and it is printing it. Right? Now it's a very simple example for building a component that can emit events. So when you write your own components, and if you want the components to emit events, you just simply need to follow this model, right? So you have a constructor function that internally calls events.emitter.call with the reference of that, and then you say util.inherits the constructor function comma events.eventEmitter. So this will prepare your constructor function in such a way that you can call the, you can use the APIs exposed by the event emitter, right? So what is available as a result of this? This is what is available as a result of this. You are able to say self.emit, right? So you are able to emit an event from here. Not only that, because your component inherits from events emitter, right? Because your component inherits from events emitter, the clients who use your component can subscribe to those events, right? Client.on message. Now what is client? Client is your constructor function, an object created out of your constructor function. Does it make sense? I'll check in the code, have a look at the code and tell me if you are able to follow. Code is checked in. Please take a few minutes, go through it and let me know if you have any questions. Okay, you go through it. I'll explain you. No issues. It doesn't take much time. You didn't miss much. So I'll explain you. Just go through the code. I'll explain you in a couple of minutes. Okay, Pablo, say basically what we tried to do was we wrote a server application that keeps listening for file changes of a particular file and lets the clients know. Okay, so initially when the client establishes a connection, it sends a JSON message. Okay, so here we are using the JSON as the serialization format. So we send the JSON message saying, the type is watching, and we send the file name. Now, since the messages can be broken into small chunks, right, across the network, when you send it in the network, the messages can be sent in different packets, and the packets may take time to reach the client. So we can't be assured that all the packets reach at the same time and all are all processed in the same sequence, etc., etc., etc. So what we do is we use a delimiter as a way by which we identify whether a particular meaningful message has been reached, and that you do using the new line. So all the JSON strings that we send from the server have to be delimited with a new line character, and you send it. Now we send two types of messages. So once the client connects, you send a message saying type is watching, file name, what is the name of the file. And another message is whenever the file is changing, right, you say the type is changed and the file name and the timestamp when it has actually changed. Now just to simulate this delay, right, wherein a message is broken into chunks and one part of it reaches earlier and early, and the other part of it takes a lot of time to reach, right? So what we have done is we manually we manually serialize the data into a JSON string format, and then we broke it into two, and we send one immediately, and then we send the other part of it after a couple of seconds, right? We send the other part of it after a couple of seconds, and as expected, the client, right, when it is receiving the messages, typically what will happen is he will attempt to receive the message as one single chunk and try to parse it. When he tries to parse it, in the first case, right, when the server sends this message, because it is sent in one packet in one content, right, it will work. It would have loaded it properly. It would have parsed it. But now, since we are breaking it into multiple chunks, the client will not be able to parse this. So this part will break when you send the second message because it is not a proper JSON string. So what we have to do is we have to bring in another component which will receive the messages from the stream, wait till a new line character is reached, and as and when a new line character is reached, it will parse the complete JSON string and then publish a message, publish an event. It will in turn publish an event saying that this is the message that has been received from the server, and that component is what we have written as LDJ. I know this is it is a custom name. We think of it LDJ as line delimited JSON. Okay, so how to write a component that will keep receiving the message from the stream and parse it till it reaches till it has a new line, and once it encounters a new line, it parses the data and then emits an event so that it tells the client that it has reached. This is the message that it has received. So that is what you have written here. Now, in order for your component to emit event, right? You need to accept subscribers. You need to emit events so that the subscribers are notified whenever you are emitting events, etc., etc., etc. Right? To do that, in Node you already have an API available called Events API. So you use the Events API, and it has a component called Event Emitter. Right? So you say events.eventemitter.call. This you pass the object, right? Whichever is the object, whichever instance that is being created, you pass that so that the event emitter can set this context to the current object, and then what you do is create a closure on the current object, and in the streams data event you parse the data. As and when you reach a new line character, you parse the data, json.parse the input, and then you emit your own event. You say self.emit a message. Now your client will not directly talk to the network layer, will talk to your parser. The parser, because the parser is the one that receives the event, and the parser is the event that receives the event. The parser is the component that receives the event, and it parses the data and returns it. So your client subscribe to that. So here it says client is new LDJ of connection, and then subscribe to the message, receive the message, and handles it appropriately. That's all. That is the only thing. So basically we wanted a case study where you can build your own components that emit events. Okay, so the way by which you do it is using this. A very simple example, simple case study to know the scenarios where your component might have to emit events, and if your components have to emit events, what you have to do. Does it make sense? Got it. Any questions? Good. Okay. So I'm assuming that you don't have any questions. So what is the next one? Next one is, how do you scale your applications? So how do you scale your node applications? As we discussed earlier, you don't have threads. You don't have the concept of threads. So the only way by which you scale your application is using multiple processes. Now we used to do this manually. Create multiple instances of the Node.js process and then load your application in multiple instances, right? So all these things we used to done manually. So what they have done of late is they have created a separate API that can do the job for you, and that is the cluster API. Okay, so that is your cluster API. So if you look at the cluster API, there is also a code sample given. That knows how to do it, right? So basically what you do is a single instance of node runs in a single thread to take advantage of multiple code systems. The user will sometimes want to launch a cluster of node processes to handle the load, right? So this code is more than sufficient to launch multiple instances of your node application. So basically you create a cluster and you check if it is a master. Basically if that is a first instance, you span multiple processes. You simply say cluster.core. How do you know how many instances to core? Based on the number of CPUs. So the number of CPUs is, you can get it from like where the OS module CPUs.length will give you the number of CPUs. So based on that you simply fork it, and when the cluster on exit you display what is the worker process ID, and it has died. And now all of this will operate on the same port. They share the port, right? They share the resources themselves. So if I take this and create a separate cluster module, so new folder day06 and new folder cluster. Just paste this and save the file, right? Now go to the prompt. Now right, now if you look at, okay, so what I will do, I'll shut down the the editor, because I showed you the other day the editor is also running based on the node process. It also uses the node runtime, right? So I shut down the editor. Now let me run the application. You'll find that there are, if you look at the task manager, you'll find that there are 5 instances of node running, right? The first one is the triggering one, and these 4 are affiliated to different CPUs, right? So I have what? I have two cores, each having two hardware threads. So what happens is it is treated as one single each core behaves like two CPUs. So I have 4 CPUs, CPU 0, 1, 2, 3. Now we have the same instance. We have 4 instances of node, one attached to each of those CPUs. We have 4 instances of the node, one attached to each of those CPUs. So that's what is happening in this particular case. Now if you want a lot more advanced, so this is kind of a little basic functionality. So if you want a lot more functionality, probably you can look at the PM2 module. So it is right there in the NPM homepage. right? So production manager for node applications. So this has some advanced functionalities using which you can host it. Start, delete, describe, right? So basically they have written some nice functionalities for accessing your modules. So how much CPU it is using, how much memory it is using, what are all the errors, etc, etc, etc. Right, so have a look at the PM2 module and see if you can use it for your applications. Any questions? Okay. Is there anything else that you want to discuss? Guys, are you there? All right. Rupa, is there anything else that you want to discuss? Okay. Please take a few minutes. I'll share you um, feedback link. Please take a few minutes and share and now submit your feedback. You have my email ID in the GitHub profile, so in case I can be of any help, please drop me a mail. I'll be more than happy to assist you. Okay, and this is a good starting point. I hope these discussions helped you to gain a basic understanding. Definitely, I'm not. We haven't looked into a lot of advanced stuff, but as at the basic level, we have learned what Node.js is and how is it different from other runtimes, and what are the complexities in building applications in Node.js, right? And what is the where does it really suit well, right? So I personally I hate using Node.js for building a web application because Node is a lot more than for building web applications. But even though majority of the use cases that you will see is they build web applications using Node.js, right? Have a look at this, in case if you are in experimenting mode. Um, I have come across scenarios. I haven't seriously looked into it, but I have come across scenarios where people use Node.js for your application logic, and engines for your serving static resources, right? So how they connect these two? Uh, so they free the node thread from serving static resources. Okay, so the static resources are served using engines, and Node.js takes care of your application processing. Okay, so they connect these two, and how they do it? They do a reverse proxy that will take care of this. I haven't experimented with it. I need to look into it, but have a look at it. Right, that will be interesting in case if you are building applications. Right, so that's pretty much from me. I'll just give me a minute. I'll give you the feedback form link. Just give me 1 second. Day 6 is checked in. Yeah, I will do it in a short while. I've just pinged a link. Is it accessible? Okay. So take a few minutes and fill the feedback form, please. Rupa, I'm checking in the code right now. Basics I'm checking. Rupa, it's done.